Hi, welcome to CSS 411's research segment on computational and algorithmic thinking. So, what exactly is computational and algorithmic thinking? Computational thinking is the thought process involved in formulating problems and their solutions so that the solutions are represented in a form that can be effectively carried out by an information processing agent. Over the past few weeks, we have been conducting research on surveying past, current, and future University of Washington Bothell students, as well as interviewing a wide variety of UW faculty and staff. Based on our CSS 411 survey, we noticed that CAT is needed at the university level because of student demand.
This graph shows that students expect to graduate from UW with CAT skills. Taking STEM students out, they actually expect to graduate with some knowledge and skills. This graph shows that students think that UW should implement CAT as a general learning goal in all courses. Taking STEM students out, the results remain the same.
We interviewed with Leslie, a research instruction librarian here at University of Washington Bothell, and received some thoughtful insight as to why CAT is essential.
The library database world, there's much more structure behind how those interfaces work and controlled vocabulary, and so you have to structure your search queries much differently using that Boolean logic. So that's a very precise example of when that skill comes in handy.
Leslie's idea is globally reflected in how we are living in a technologically oriented world, and that not being able to understand the underlying mechanisms, how the code works, performance, and so on, is a disadvantage for non-technical majoring students. We interviewed with Dr. Robin Angotti, a professor in the Engineering and Mathematics Department here at University of Washington Bothell.
So I actually think computational thinking it's kind of like literacy, right? Literacy isn't about reading words on the page. Literacy is about being able to read a paragraph and make sense of what the storyline is, right? It's the same way in mathematics. I can teach kids how to do algorithmic procedures where they're just doing a procedure over and over and over, but that doesn't make them literate in mathematics, and that doesn't make them literate in quantitative thinking. I think computational thinking is more what we're thinking in terms of literacy, right? Because we're helping people become literate in how to use quantitative information in real ways.
Since a lot of individuals miss out on this type of knowledge, professionals in the industry often lack a diverse background, which raises a social justice issue.
There's kind of a social justice element. Information literacy it's about empowering people to be able to find the information they need to be a productive citizen, community member, make professional decisions, personal decisions, and having access to that information and systems that it lives in, knowing how to navigate them well, and knowing how to critically assess that information and use it appropriately. That I think is a benefit that could come out of students having a stronger grounding in computational thinking.
We also interviewed with Amber, manager of the QSC here at UW, and she spoke about the benefits of integrating CAT across career, education, and day-to-day life.
If nothing else, just to help organize their day. I think it's necessary for any kind of project management, whether that project be getting through this class in these 10 weeks, or getting through this assignment in the next 24 hours, or how do I get myself from point A to point B, on the public transportation system. I think that's very, very applicable to life. And I think that the university level is where a lot of students are coming out from under the support of their parents and their high school system. They're more independent. They need to develop those skills in order to just function and cope in society.
Most of the research that we found online was about integrating CAT into K-12 classrooms. Computer Science Unplugged is a program that teaches kids about computer science topics without using a computer. Globally, many countries, including China, Singapore, and the UK, currently include CAT in their K-12 curriculum. There have been some life science and CAT courses being introduced at both the introductory and intermediate level at Purdue University as well as other institutions. Currently, Robin is collaborating on a data science and biology class that introduces CAT in an interdisciplinary form.
I'd like to see us, and I'm trying to work that way, offer some kind of classes, certainly at the freshman level, so that people can start out really early on thinking about data in whatever field they choose. So one of the things I'm trying to do personally is another colleague and I, a biologist and I, are trying to teach a class called Data in the Sciences. I'd like to see that class be used no matter what, but we're taking her data and we're teaching kids how to analyze that data and look at that data and visualize it. Because when you think about data and big sheets of data, and you look at programs like Tableau, for example, it's really hard to make sense of how to visualize that, right? That's the hard part. You get all this data, so what? So then you make a visualization because you have this great software that can let you drag and drop, but what does that data mean? And you have to be able to then interpret that data. And more importantly, then you have to be able to tell what the story in that data tells other people that don't understand necessarily the underlying problem.
Initially, from our research, we were thinking of proposing a solution that integrates CAT as a learning goal across all majors and disciplines at the University of Washington-Bothell. However, there is a huge problem, a gap in teaching. Many teachers do not know how or are not comfortable teaching this subject matter.
That's a huge problem. How do you teach teachers how to teach that way? Because none of us have thought, I mean, we grew up before there was any internet and data and whatever, right? So we still have, there's no textbooks to help you teach that.
After hearing Robin's viewpoint, we have refined our proposal to focus on making a series of classes for everyone based on statistics, data visualization, and tool literacy. We also propose that CAT become a learning goal in the future when instructors are prepared to teach this subject matter. As technology is prevailing and becoming essential in a day-to-day life, integrating CAT into school, work, and daily activities will be an essential part of human literacy. Integrating CAT as a series of classes will prepare us for a future where teachers can confidently and effectively teach this as a learning goal and skill throughout a student's education. Everyone should learn to drive a car, but not everyone needs to learn how to be a mechanic, and CAT gives you the skill set and tools to drive today's car. Thank you for watching. We hope you learned something, and this is Group 2 from CSS 411 signing off.